Be careful, this experiment deals with strong acids, and brominated compounds can be carcinogenic. Be sure to wear proper safety gear such as gloves and goggles. In general, alkyl halides are important molecules used in a multitude of chemical syntheses. Some uses of alkyl halides are in the synthesis of ethers or the formation of double bonds. In this video, we're going to be making an alkyl bromide, and one common use of an alkyl bromide is in the Grignard reaction. The Grignard reaction most commonly uses alkyl bromides and allows for the formation of new carbon-carbon bonds. In this video, I'll be making bromopropane, which I will use in a future video in a Grignard reaction to make butyric acid. Although I'll be producing one specific alkyl bromide in this video, this procedure should be able to be applied with a couple tweaks to produce alkyl bromides from most simple alcohols. You'll need 20 grams of sodium bromide, 15 milliliters of concentrated sulfuric acid, 11 milliliters of propanol, or 0.15 moles of another alcohol, saturated salt solution, and saturated sodium bicarbonate solution. First, add 20 grams of sodium bromide to a round bottom flask. Then, add 15 milliliters of water. To this, I added 11 milliliters of 1-propanol. The solution was placed on an ice bath, and with strong stirring, 15 milliliters of concentrated sulfuric acid was added dropwise. We keep the solution in an ice bath and add the sulfuric acid slowly because we want to keep the solution as cold as possible, and we want to keep the concentration of sulfuric acid in the reaction as low as possible. When the sulfuric acid is added, it reacts with sodium bromide according to the equation shown above. If the temperature of the solution or the concentration of sulfuric acid is too high, we risk dehydrating the hydrobromic acid to bromine gas. When the temperature is kept low and the sulfuric acid is added slowly, the amount of bromine gas produced should be negligible. As more and more sulfuric acid is added, slowly, sodium bisulfate salt will precipitate out. The entire purpose of these steps is to make hydrobromic acid in situ. If you have access to hydrobromic acid, you can obviously skip the step of making it, so you can simply mix your alcohol with the hydrobromic acid and proceed on to the next step. After the addition of the sulfuric acid, you'll probably be left with a large clump of sodium bisulfate salt. This is fine, so don't worry about it. Next, set up a reflux and reflux the reaction for about 45 minutes. Next, I set up a small distillation apparatus. In the preparation of alkyl bromides, this is one of the few steps that is going to vary. My product was 1-Bromopropane, which has a boiling point of around 70 degrees Celsius, so I collected everything below 100 degrees Celsius. However, if your product is 1-Bromobutane, you're going to have to distill everything and collect everything below of about 120 degrees Celsius. So how you carry out this step will depend entirely on the product that you are trying to isolate. At the very least, you should know the boiling point of what you plan to collect and whether or not it forms an azeotrope with water. Alkyl halides tend to be quite volatile, so you should cool your collecting flask with ice. The product collected from the distillation was then added to a separatory funnel. And then 25 milliliters of water was added. At this point, because 1-Bromopropane is immiscible with water, 2 layers formed. Next, the 2 layers were mixed thoroughly and the separatory funnel was vented frequently. The lower bromopropane layer was recovered and the top aqueous layer was discarded. The bromopropane was added back to the separatory funnel. Then, 15 milliliters of saturated sodium bicarbonate solution was added. The 2 layers were mixed thoroughly, and again the lower layer was recovered and the top layer was discarded. Then, the bromopropane was added once again to the separatory funnel. This time, 15 milliliters of saturated sodium chloride solution was added. The layers were mixed and the lower layer was recovered to a round bottom flask. A simple distillation was set up and all of the distillate below 71 degrees Celsius was collected. Again, this step will differ depending on what alkyl bromide you formed. The distillate that came over was a little bit cloudy, so I dried it quickly by passing it through a passer pipette packed with sodium sulfate. The final yield in the end was about 9.5 milliliters of bromopropane, which represents a percent yield of about 70.